Last time we were working in section 2.3 and we had started talking about intersections and unions, and in particular we were looking at how we shade in a Venn diagram to represent those kinds of statements. And just as a reminder where we were, I want to talk to you about how we did this one, which I know you remember, but just to remind you, we had drawn two circles because there were two letters mentioned, A and B. Both of them had complement involved, so that involves what we're going to write down in terms of the numbers afterwards. But we put numbers in all of our regions, 1, 2, 3, and 4. And then we identified which of the numbers were located in not A, or A complement. Same thing for B complement. And then we took the union, and if you remember, union means everything combined, all of it. You know, it's the family picture, it's the marriage ceremony, that kind of stuff. And we had gotten to the point on this one where we at least put the numbers in the different regions because we had 3 circles. There's more numbers. There's 8 numbers, in fact. And we're going to take a look at how this would pan out when we have 3 sets we're considering. So you'll notice that there are parentheses that tell you where to begin, right? So just like with order of operations with algebra, you work inside the parentheses and then you move your way out. So the inside of the parentheses is an A. So we're going to write down A, and it's not complement this time, it's just A. And we're going to list all of the numbers that are in that region. So what numbers are inside of circle A? Any part of circle A? 1, 2, 4, and 5. The other set that's inside the parentheses is B. Again, it's not complement. It could have been, but it just wasn't this time. What numbers are inside circle C? I'm sorry, circle B. Okay, so everybody good so far? Okay, we're just listing those sets out in terms of the numbers that are in those regions. And then also inside that parenthesis, it indicates that we need to join those sets together with what symbol? What is that between them? An in, or for intersection, right? Intersection, what does intersection mean? What are we looking for? What's common to both? In other words, what they both have, what's repeated. And what do you see that's repeated? 2 and 5. Cool. So those are our intersection parts, 2 and 5. And if you look back at the picture, you should agree with that. Are those two numbers in the overlap of the two regions, A and B? Yes, they are. Okay? And again, I understand you might be feeling like right now, well, why did I write down all those numbers? I probably could have just told you that just by looking at it. And you probably could for this one. But once you get complements in there and other things, it becomes more difficult to just look at it and make those deciphering remarks. So it's easier if we do this for all of them, at least the easy ones at the beginning, so that when they do get difficult, we have a way to handle that. Okay? All right, we've done the inside part of the parentheses. Now we're moving to the outside part of the parentheses. We have a second set, or really a third set, to consider, and it's the set C. Again, it could have been complement. It's just not on this one. So what numbers are inside of set C? 4, 5, 6, and 7. Good job. And we're going to join these two sets together, because you see these are sets, right? One of the sets is A intersect B. That's one set. And then the other set is C. And what symbol are we going to join these sets together with? U for union. Good. So I need the union. So what is included in a union? All of it. You get everything, right? It's the marriage ceremony. So you don't repeat the numbers. So if there are repeating numbers, which there are on this one, we'll only list them once. So this is 2, 4, 5, 6, and 7. And you don't really even have to put them in numerical order. That's just sort of my OCD kicking in right there, you know? Some of you know what I'm talking about, right? Got to put them in order. Okay. We've done all the real work. All the mathematics is done right there. But we haven't actually answered the question or done what the question told us to do. What did the question ask us to do? Shade a Venn diagram, right? So what am I going to have to do to finish this problem then? All right, so shade 2, 4, 5, 6, and 7. And that's actually the answer to the question, the shading. All right, but the work that supports it is all of the numbers and the way that we joined them together. I will guarantee you that you'll do some kind of shading on the test. And I will also guarantee you that if you shade only, even if you've got the right pieces shaded, but you don't have any work to support it, you're not going to get credit for having done the problem right. Yes?
For the test, for labeling it, do we need a label like you did so many shading details shaded?
Yes, you'll need to label like numbered regions. They wouldn't, I mean, and I don't mean to be like control freakish here. I mean, they don't actually have to be in the right same, I don't want to say right, but the same places that I put the numbers. They don't even have to be numbers, they could be letters. But if you are checking it like with your book, this is sort of the standard, the way that they set it up. And so if you're wanting to sort of just be consistent so that you can check your answers easier, you'll always see them set it up this way. So, all right, we're going to do another one. Same idea. How many sets do I have? 3. So we're going to need 3 circles, right? The 3 circles all overlap, like the Olympic rings we talked about last time, right? And they are sets A, B, and C. And we'll put the U for universal on the outside. All right, so inside the set of parentheses, well, actually, we need to label our regions with numbers, okay? So again, if we're keeping with the numbering scheme, if you will, that your book uses, they do 1, 2, 3 across the top, 4, 5, 6 across the middle, 7 in the bottom, and 8 on the outside of the circles, but inside the rectangle. All right, so taking a look at the whole thing we're asked to find, what piece are we going to do first? A. It's the first thing listed inside the set of parentheses. And what numbered regions are inside of circle A? 1, 2, 4, and 5. Is everybody good on that so far? Okay, what's the next piece that I need to find? Good. It's B complement, or the complement of B, or not B, any of those kinds of descriptions. So what does complement of B mean? Right, everything that's not in circle B. And what numbers are not in circle B? 1, 4, 7, and 8. And how am I supposed to join these two sets together? Well, before then, I need to join them together first. It also happens to be an intersection, right? So I'm going to join set A and B complement with an intersection. And the intersection means what? And what they both have, what they have in common. It's the duplicates, it's the repeats. What numbers do you see that they both have? 1 and 4. So it's going to be 1 and 4. Okay, so now I've got one complete set, the inside of the parentheses finished. What's next? Good. I move outside the parentheses and I see that I've got the complement of C. And complement, you just told me a moment ago, means not in C. So what numbers are not in C? 1, 2, 3, and 8. Don't forget 8. It's easy to remember, just ignore him because he's not inside of a circle, but he's still there too. And then how am I supposed to be joining A intersect B complement with C complement? Another intersection on this one. So A intersect, B complement, there we go. And I'm supposed to be intersecting that with C complement. So again, what does intersection mean? What's common to both? And what is common to both here? Just plain old 1. Not very many things this time, right? Not very many. It's just 1. So the shading's super easy. Back in my circle, all I shade is region 1. What do you think? Can we shade? Here's a cool story. I'll wait, flip to the next one. This is not actually how I used to teach this information. I had a student show me that this is how somebody showed to her somewhere along the way, and I thought, I liked that a way a lot better than the way I was teaching it. And I changed what I was doing because I thought it was so visually helpful. So that's kind of a cool fact. Okay, so we've got the shading of the Venn diagrams down. We understand which regions we're talking about. And the reason that we're doing that is to actually move into what's coming next. This looks like a mess, okay? But thinking about what you've really got here, what I want you to make the decision of is how many different regions are we talking about? How many circles am I going to draw? What do you think? 3. I've got a rectangle, and I only need circles for however many letters are mentioned. So this mentions 3 letters, A, B, and C. So I'm going to draw the Venn diagram for circle A, circle B, and circle C, and of course our universal set. Now let's go back to the problem and read a little bit more about what we're going to do this time as compared to what we did last time. It says, draw an appropriate Venn diagram. Okay, so we've already kind of started that. It says, and use the given information to fill in the number of elements in each region. Now that's different. See, we put numbers over here, but we just sort of put them in as placeholders, a way of identifying a location, right? That's like what your address is. If I ask what your address is or your phone number is, it identifies an object, your phone, or a house, your place you're living, right? It's an identifying mark. But this right here is actually counting something. Remember what that put that in front of it? It means the number of items in that, right? The number of how big something is, the size of it. That's what it's doing for us. So now if you take a look and we just read them in order, the first one that it mentions is it says, right here, it says N of A is 24, right? So that's telling us that everything that goes inside of circle A, all of these pieces, and there's 1, 2, 3, 4 regions, right? All of those combine to have 24 items in them. Okay? So in other words, like if I had, oh, didn't mean to throw the chalk at you. If I had a 10 here and a 12 here and a 2 here and a 0 here, that would add to 24, right? Trust me, I just added the numbers up, so I just made them up, okay? But that was just one way of splitting up the number 24, right? There'd be a lot of ways of splitting up the number 24, agreed? Yeah, so we probably don't want to start with this idea of there's 24 items in this big circle with 4 parts. Agreed? And if we don't want to start with circle A, we certainly don't want to start with circle B or C either. It doesn't help us anything. So the first sort of line right here, all of these guys, useless at the moment. Okay, so just ignore them for the moment. Let's move to line 2. This says A intersect B. Well, A intersect B is this football shape right here, right? How many regions are counted in A intersect B? Just 2. This top piece and this middle piece, these 2. Those have to add up to 10. Okay, so we have fewer ways of doing that than the last options, but we still have a lot of options, right? 10 and 0, 0, 10, 9 and 1, 1 and 9, all the way to 5 and 5. There's a lot of choices. So we still don't like that choice to do that. So that sort of rules out this one, and this one. Those 3 that are all intersections around, in the middle of sort of row 2. Row 3. It's a good place to be. Sally's like, yeah, I like that spot right there. This says A intersect B intersect C. Where is that? Right in the middle. How many regions? 1. So when they tell me that A intersect B intersect C has 6 elements in it, and I only have 1 place to put the 6, that's where I want to start. So we're going to put a 6 in the middle there. Again, it's not identifying a numbered region. It's actually identifying how many objects are there. So you have maybe 6 people, all of whom in the middle are from Oklahoma, making straight A's in their elementary ed majors, or whatever, okay? We've got 3 different descriptions, and these 6 people in the middle count in all of those descriptions, right? So, as we do them, I'm going to mark them out so that we remember that we've done that part. The very last piece on here says N of U equals 50. What does that mean, do you suppose? So 50 goes in the universal spot. There's a little bit more, all of them added up, right? Is that what you mean, Shelby? Okay, good. So all of the numbers inside the rectangle with all the regions, all of them add up to 50. So that's like definitely the last thing I want to deal with. Does that make sense? So I'm going to do that very, very last. So I've already done one piece, the very center, and I've got to sort of move out from there, right? It's got to expand what I can do. And in fact, if you look at the middle row that we just ignored a moment ago, this one right here, All of these I can actually make use of right now. Let's just start on the left-hand side and I'll show you what I mean. This one right here says A intersect B is 10. Well, that's this piece right here, right? It's supposed to be 10. There's 2 regions. I already have a 6 in one of them, so 4 goes in the other piece. Fantastic. So now I know that there are 4 right here because 6 plus 4 is the 10 that it referenced. And we can continue across sort of the middle of this row now. It says B intersect C is 8. So B intersect C would be this piece right here. Agreed? So it's supposed to add up to 8, which means I need 2 more. I heard you guys say it right here. And then I can mark out the B intersect C part. The next one says A intersect C. That would be this piece right here. And as this says it's supposed to equal 15, there's 9 remaining for the outer part right here. And we can mark it out. Yep, Caitlin?
Would it be 9 plus 6 plus 2?
No, because 2 is not inside of circle A. Yep, we want to make sure that we're inside circle A and inside circle C, like both. Okay, so are we good with the intersection spots? We already said that N of U, the 50, is the last thing we want to do. So now we're sort of left with what's in the top row, right? The top row says N of A is 24. Well, circle A is this whole circle now, right? That's terrible. I can't seem to highlight it very well. But you know what I'm talking about, right? That whole circle up there. Originally, I didn't want to start there because there were 4 regions. But now, 3 of the 4 are filled in with 9, 6, and 4. What's that totaling up to so far? 19. But I want it with the outside of circle A to add to 24. So I need 5 more. So there's a 5 that needs to be represented outside in circle A only. And then I'm marking off the N of A as 24. Cool, cool. N of B is also 24. So circle B, what numbers are currently inside of circle B? 4, 6, and 2, which adds up to 12. And how many do I need? 12 more to add up to 24, right? So there's 12 more in the outer part of circle B. Now we've got circle C, supposed to be 26. How many are already there? 17. Yeah, I agree. 17. So how many am I left with needing? 9 more. Good. And that would be right here in circle C. 9. Somebody's got to grab a calculator, not add it. Well, you don't have to grab a calculator, but you can add them all together. It's not 50 yet. It's almost, though.
47.
It's 47. That's correct. It's 47. So how many more do I need? 3 on the outside of circle. Outside of the circles inside of the box U. Now, there are a couple examples where they do this in your book where they don't necessarily describe them quite like this. They'll describe them in words. So I'm about to do one in words, but they'll use statements like this. A only. Now, if they told you something was an A only, that would be right out here, right? That was not what I meant to do. I meant to do this. So if it uses the phrase A only and not A, that's different, right? If you put the word only with it, it means it's identifying one very specific piece of the circle A. This didn't do that. It just said A, so it would represent the whole circle A. So occasionally there are differentiations like that, just to be aware of that. All right, so let's show where this is going to be used. This is a way of identifying description or identifying locations for things when we have a word problem. That's what we're using the Venn diagrams for. We have 2 examples, one that is a little bit of a small example, this one, and then the next one where it's a little bit bigger. Joe Long works on albums for musicians. Last year he worked on 12 projects. He wrote and produced 2. he wrote a total of 5, and he produced a total of 7. And then it's going to ask us a bunch of questions about how Joe Long worked on these projects. So we're going to draw a rectangle, and I need to know how many circles need to be inside my rectangle. 2 or 3? It's always going to be 2 or 3 for what we do. 2. Do you know what they are, Shelby?
They are the ones, if you label them A and B, the first circle is the ones that you wrote.
Okay.
And then the second one will be the ones that you produced, and then in the middle it's he wrote and produced.
Good. Okay, so these are 3 different categories. It's just that when they overlap, they create the third category. Did you guys hear that and how Shelby described that? I thought she described that very well. So he wrote some, he produced some, he did both on some, and in theory, there's maybe some he did neither on. Maybe he did something else. Maybe he sang in them. I don't know. He did something. He was the drummer. Okay, so we need to figure out where all of our numbers go. It says that he worked on 12 projects. Where does that go? And what is that telling you? That's my universal. So that's like the last thing I need to use, right? Okay, good. It says he wrote and produced 2. That's the both. The overlap part, right? So 2 goes right here. Wrote and produced. So sort of if I'm marking them off, the wrote and produced 2, I've done that part. It says he wrote a total of 5. Like this? Does everybody agree? Okay, if I put a 5 right there, how many did he write? How many projects did he write? 7. Did he write 7? Ooh. Okay, so I actually have to subtract to get the 3 to put there on this one instead. That's a really easy thing to make a mistake on. Right? I had a 5. It told me he put 5, so I just put a 5 in. Be careful. This one wasn't a 5. Now, if it had said he wrote 5 only, right, that's all he did on 5 of them, then the 5 would go there. So you have to be paying very careful attention to the language. Okay, very good. So we've got the wrote a total of 5. And then it says he produced a total of 7. All right, so 7 minus 2 would be 5, and 5 will go in the outer part of the producing circle. So how many projects do we have currently represented in our diagram? 10. How many did he total have an input on? 12. So what does that tell you? We put a 2 out here, and we can also still call this the universal set U. Okay? All right, so you guys have space on your paper where you see your picture and you see your questions. I don't. So hopefully you can look at your picture while I look at mine on my paper. And we're going to go back and we're going to answer the questions asked. Typically speaking, the answering the questions part is not the hard part. The creating the diagram is where where more work is involved. All right, so the question on part A says, how many projects did he write but not produce? 3. So we're just looking at our diagram, and it's this piece right here, right? Second question, how many projects did he produce but not write? That's 5. And that's the part that's out here. And the third question says, how many projects did he neither write nor produce? And that 2 would be out here, right? Now, as long as your numbers match your diagram, then you would be getting credit for the numbering part here, even if your diagram's messed up, okay? So do make sure that your numbers are coming from your diagram. Even if you do end up with a diagram that's wrong, you get the credit for having done this part right. Does that make sense? Okay. You ready for the fun one of the day? Well, of course we are. Definitely. Let's do the fun ones. Yeah. Okay. A youth group was asked questions regarding the songs they had learned as children. Upon surveying the 34 youth, the following were obtained. 15 had learned Jesus Loves Me. 19 had learned the Bible. 28 had learned This Little Light of Mine. 13 Jesus loves me, this little light of mine. 15, Jesus loves me, the B-I-B-L-E. 14, the B-I-B-L-E, this little light of mine. 13 had learned all three. Questions want to know how many had learned, and they give 4 questions after this right here. So, I need to create a Venn diagram because there's a lot of information going on. It's going to be a lot easier to work with if I have a visual for it. I need a Venn diagram that has how many regions? 3. What are the regions in this diagram? Okay, I'm going to abbreviate my circles with just one of the words of the title. So Jesus, Bible, and light. Is that okay with you guys? Okay. These are where I put them, which, oh my goodness, it doesn't match where they are on my paper. So now I've got to be real careful looking at my paper. I don't put numbers in the wrong locations for my paper. All right, so here are my 3 circles. And where should I start with all of this list of details? At the end. And that doesn't always happen. It just happened here, right? It says 13 had learned all 3. So where will that go? Right in the middle. I have 13. Awesome. What would you like to do next? Okay, so it sounds like Hannah would like to go from the bottom up, at least at the moment, right? Is everybody good with that? Cool. It said 14 had learned the B-I-B-L-E and this little light of mine. Okay, had learned, oh. Yeah, that's right. All right, so 14 had learned those 2. B-I-B-L-E and this little light of mine. So I think that's this piece over here. Am I getting the right spot in the picture? Cool. And Hannah said I need one more out here. Are you guys in agreement with Hannah? Looks good? Nice. That adds up to the 14 that we expected to see there. Okay, working our way up from that, we have 15 had learned Jesus loves me in the B-I-B-L-E. So where's that number? Where am I going to put what number? That was 2 questions in one. Did you hear that? Where and what? Where, Sally? Jesus and Bible, so... You want to put a 1 above 13?
No, I meant
the location above 13. Okay, so in this area right here, you want to put a number. Am I right? And you want to put the number 2. Are you guys good with that?
Yes.
Excellent. So going back to our list of numbers, we've now taken care of this one. Working our way up, the next one says 13 had learned Jesus loves me and this little light of mine. Where will that be? Okay, here, Caitlin?
Yes.
Okay, and what number shall I put there? 0.
0.
And it is totally fine to put the number 0 in your diagram. It is not fine to put negatives. Don't do that. Okay, no negative numbers. But the number 0 is perfectly fine. Okay, so 0 will go there. Very good. All right, so we've taken care of all of the duplicating numbers, right? The ones that say this and this. If I keep working my way up, the next one actually says 28 had learned this little light of mine. So this little light of mine is my bottom circle. It's down here. And this tells me that this whole circle has to do what? Yeah, have to add up to or equal to 28. How many are currently in my circle? 14. So how many are missing? 14. So I will have a 14 in the outer part of this little light. All right, the next one up says 19 had learned the B-I-B-L-E. So the B-I-B-L-E is over here. How many are currently there? 16. So how many are missing? 3 to go out here. We're getting so close to done. Taking care of that one. The next one says 15 had learned Jesus loves me. So this circle for Jesus already adds up to what? 15. And what was it supposed to add up to in total? 15. So what does that tell you? 0 goes here. That doesn't mean 0 people knew Jesus loves me, right? It means 0 people knew that only. That's what that means. All right, am I done? Nope, but I'm close. What do I still need? Excellent. So if I add them all up, or if you add them all up, how many do you get? 30 what? 32? 33? Double check. We need to know which one it is. Is it 32 or 33? 33? I'm hearing several 33s. We'll go with 33. Okay, they all add up to 33. What is the total supposed to be if they add up to? Okay, supposed to add up to 34. So how many more do I need? One. Where? In the rectangle part, right? But not in the circles. Okay, cool. All right, so this is my diagram. And I need this to answer the questions over here. And because I can, I just copied and pasted it. How cool is that? Yeah, it's really nice. Okay, here's my diagram, and we're going to use it to answer our questions. The first question said, how many children had learned A, exactly one song? So looking at this diagram, which parts of this diagram are the exactly one song parts?
0, the 3, and the 14.
Okay, does everybody agree with Caitlin on that? Good, I do too. And in fact, I even like how she said it, because that will be quite useful. 0, 3, and what did we say, 14? 14. Because if you write those numbers down and you've got an error, then I'll know where the error is. Do you see what I'm saying? So it's very helpful to me and to you in terms of partial credit and things like that if you will give me a little bit of work to show me where you're actually getting your numbers. And if I add those together, what do I get? 17. Okay, the next one says at least 2 of these songs. So somebody help me out. What does at least 2 mean?
2 or more.
2 or more. And in the picture that we're looking at, that actually means 2 or 3, because there's only areas where things of up to 3 overlap, right? So 2 or 3 songs. So let's start with the 2. What numbers are in the 2 songs region? 0, 2, and 1. And in case you're wanting to know where those came from, they are these 3 pieces. Can you guys see that blue? It's really light. Make it darker. How about this? It's a little darker. Those 3 regions, those are the 2 only. Those kids knew 2 songs. And then I need to have the possibility that they knew 3 songs. And how many knew 3 songs? 13. So 0, 2, 1, and 3 all add up to what? 16. How about none of these songs? That's the one lonely kid on the outside of my circles, right? 1. And this little light of mine only, where's that? 14. Totally a possibility. That song is sung in secular circles as well. Okay? Any questions about processing through the Venn diagrams? Okay, so we started with the shading to give us some sense of these locations so that we could get to this point. Do you guys see that? That's how we got here, and we're able to actually identify which pieces of these are the only, the ands, the ors, things like that.